thank you for joining us. Apologies about the technical difficulties. I hope for you that the weather is better in Princeton than it is in Pittsburgh, but I suspect probably not much. We still have a few people coming in and helping themselves with food. They all had to brave the cold as they move from one classroom to the next. But today is the first seminar of the semester. We've been running this for 12 years, and we've had a number of very prestigious speakers, as our speaker today, Arvind Narayanan. Arvind, please bear with us just for a few more minutes as we discussed. Because this is the first seminar of the semester, there's a little bit of logistics that Professor Hannah Habib, who is my co-conspirator in this seminar this semester here, and I want to go over for the next few minutes. Hannah, would you like to actually take the lead on this, and then I'll introduce Arvind? Okay. Does that work?
Yeah, that works. Do you want me to share slides?
If you're able to. If not, I think we can probably cover this without slides and just refer people to the canvas.
Yeah, sure, no problem. Arvind, is it okay if I take over the screen share for a few moments?
Sure, go ahead.
I know it was a bit of a trouble getting it. Okay. Hello, everyone. Welcome to our Spring 2025 seminar series. I'm Dr. Hannah Habib, and I am one of the co-instructors with Professor Noman Sadeh. Again, we've been really fortunate to have some prestigious speakers, including the one we have today, to speak in our seminar series over the past several years. And we try to invite speakers from all different perspectives, from industry, from academia, from nonprofit organizations, from government. So if you've taken a glance at our schedule for this semester, you'll actually see people from all different types of organizations. Logistically, this course runs on Canvas, so any slides or readings or assignments will be available there. If you don't have access to Canvas, and if you're registered for one of the course numbers, please let me know. If you're here just for the lunch and for our amazing speakers, that's totally fine too. You don't have to register for the course. But for the 3-unit course number, there are some assignments involved in participation, which is what we're covering in these first few moments before we hand it off. So first note I'll make is regarding attendance. So we expect attendance either on Zoom or in person here every class. And asynchronous attendance is okay for anyone in the remote part-time section of this course number. To help with keeping attendance, it'd be great if everyone could join on Zoom, even just on their phone, so we can just mark that you were here. And I mentioned participation. So in addition to attendance, we expect students to ask questions, at least 1 to 2 per talk, and really engage with the speaker. One additional note about attendance is that one absence in the entire semester is excused for any reason. You don't have to let us know about that. And I mentioned some assignments. These are 3 summaries of different presentations that speakers gave in the seminar. For each summary, we expect about kind of a 2-page write-up with a discussion of 2 challenges that were identified by the speaker or that you kind of identified with related to their topic. There's more guidance related to these assignments in Canvas. We have 3 deadlines during the semester related to these assignments, so please make note of those. They're kind of evenly spaced out, so hopefully no one gets behind. And again, for part-time remote students who are allowed to kind of watch these recordings asynchronously, they will submit 4 of these talk summaries for their grade. So a quick preview of our schedule. Again, we have a lot of people from kind of different perspectives of privacy. coming up. And we won't have a seminar over spring break, so that's one important date. I think Carnival is another date, which is not marked on this calendar. But any updates on our seminar sessions will be available on our website, which is also linked on Canvas. So you can keep up to date with the schedule there. I'll pass it up.
Thank you so much, Hannah. So unless there are any questions, and obviously you're all busy chewing on your food, so that's a good time to say this. I'd like to proceed and introduce our guest speakers. So it's really my great privilege here to welcome Arvind Narayanan from Princeton as our speaker today. I believe, Arvind, you might have spoken at this seminar once in the past, but probably some number of years ago. And so it's really nice to be able to welcome you back and to have you again as a willing speaker at this seminar. As I've mentioned, we've been running this seminar for 12 years today and at this point, and expecting to run it for many more years to come. Participants who brave the cold include primarily master's students in our process engineering program, as well as PhD students. We also videotape this seminar, assuming that this is okay with you, and I think you've provided your consent already. Attendees also include typically alums from the program, as well as people who might be watching the YouTube video that we're going to be posting later on. And so Arvind is a professor at Princeton, where he's been for now about 12 years, I believe. He's also a director of the very prestigious Center for Information Technology Policy, which was started by Ed Felten some number of years ago. Arvind, I think, got his undergrad at IIT Madras, if I remember correctly, and his PhD at UT Austin. And he also did a postdoc with Dan Bonnet at Stanford. He initially made his name working on the Netflix data set that was released, I think, around 2005, 2006 or so, to encourage people to come up with new recommendation techniques. And that's actually closely related to some of the things he's going to be talking about later today. So he showed that this corpus that had been released to encourage the development of new machine learning data mining techniques was actually relatively easy to de-anonymize, basically combining some of the data in that data set with data released by IMDb, if I remember correctly. And that made a ton of noise. And he didn't stop there, however, and he's done a number of other things for which he's very famous for. He was also a key player in the Do Not Track effort, contributing to the standardization of that technology with Jonathan Meyer, if I remember correctly. And he's obviously published an awful lot of other very well-cited articles at the intersection of machine learning and privacy, showing in particular how much data is being leaked, how out of control many data flows are. And most recently, his work has focused on AI and in particular predictive analytics. He's written a book recently referring to this technology as snake oil, and he's going to tell us more about that. He's always a very, very interesting speaker to have. He's going to challenge some of your thinking in various types of areas, and I'm very much looking forward to his talk. So without any further ado, Arvind, the floor is yours, and very much looking forward to your presentation today.
Thank you, Norman, for that very kind introduction. Hi, everyone. Hope you can hear me.
We can.
Excuse me. Norman and I go way back, and so you got to hear about things from my distant past, as well as things I've been doing more recently. So what I'd like to speak to you today is about one of the things we've been writing about recently, which is a predictive decision making. It's sometimes called AI. It often uses machine learning. That aspect is a little bit less relevant here. And this is based on a paper called Against Predictive Optimization. It's jointly authored with Angelina Wang, Sayash Kapoor, and Solon Barocas. And these arguments are also a big part of our book, AI Snake Oil. And I'd love to make this interactive. That's why I've structured this as case studies. I hope that's okay. And I was happy to hear that you're actually required to ask questions. So I think, if you want to participate as we do these case studies, I think that will work really well. In any case, let's get into it. You might wonder, though, in a privacy seminar, why am I talking about automated decision making? That might be obvious to some of you, but just to make sure we're all on the same page, let me give you an example just from today, actually, something that was in the news today, which is an insurance company using phone apps that people might not recognize are tracking their location, and the insurance company hovering up people's location data from these apps, such as Gas Buddy, right, which people are using for a totally different purpose to find cheap gas prices and that sort of thing. So clearly people are upset. There is even a lawsuit about this. Why are people upset, and what does that tell us about the connection between privacy and automated decision making? So one reason that people might be upset is for kind of more classic privacy reasons, because they have an interest in keeping their information private in the sense of secret. It's none of your business where I go and who I talk to. We're interested as a society in preserving people's freedom of association. If the insurance company is collecting this information, then the government might misuse it for surveillance. It might be breached by hackers or attackers, and it might lead to stalking. So those are all kind of more classic privacy concerns. That's one possibility. But the more likely possibility, and what's at play here, is that people are worried about the exact reason for which Allstate is collecting this information. Not so much unintended side effects like the data getting hacked, but the insurance company is collecting this information so that it can analyze people's driving behavior and change people's insurance premiums, or cut some people out of insurance if the company judges them to be too risky or whatever. Right, and so that's the reason there's a lawsuit here. And that is a sense of privacy, which really gets at our discomfort with our private data being used for making these decisions about us, especially in a way that's not transparent and accountable. And so the bottom line is both privacy and automated decision-making have as one animating concern this idea that we might be subject to adverse decisions based on a surveillance of our data. And that's the reason why a lot of the same people tend to work on both of these topics. A lot of the interventions tend to be the same. The GDPR, for instance, has a focus on privacy in the traditional sense, but also for automated decision-making. And you can imagine how a law that prevented Allstate from tracking this data from third-party apps would address the automated decision-making concern, because they wouldn't have the data, so they couldn't use it for adverse decision-making. But also a law that said you're not allowed to make decisions in this way. You have to be transparent about how you make decisions with your customers, something like that. That didn't address privacy at all in the traditional sense. Would, in fact, improve privacy because it would remove the incentive for Allstate to collect this data in the first place, because the data is no longer useful to them. So you can see the really close relationship in many ways between privacy and automated decision-making. Okay, so that's all I'll say about that. So for the rest of this, I want to talk about what we're calling predictive decision-making. And that's one kind of automated decision-making. Predictive is, I'll be more precise in a few slides, but for now, for intuition, it's the thing that happens in the criminal justice system. For instance, someone's arrested, their trial might be months or years away. Should they be free or should they be jailed? Should bail be set? What should the bail amount be? Data is typically used for informing all of these decisions, and the decisions are often based on predictions of, if this person were to go free, will they commit another crime in the time between now and when their trial is, right? So a prediction of recidivism. And this has become widely deployed, pretty normalized. I'll tell you in a second all the various different domains: education, hiring, insurance, medicine, and others, in which this kind of logic is deployed in order to make consequential, life-changing decisions about people. And we wrote this paper because we're questioning whether we should be using this kind of predictive decision-making at all. And it can be hard to make that point just because we've kind of accepted as a society that this is what we're doing, even though I feel it should shock us that we have accepted pre-crime, this idea of jailing people based on a prediction that they might commit a crime in the future. Science fiction has warned us about that for so long, and we used to be horrified about it, but now it's happening everywhere, and we have accepted it. And so that leads to my first case study, and this is from the paper. So to get people to think about the ethics of predictive decision making, by considering a setting where it's not currently deployed and asking people to think about, okay, well, how would the world change if we were to start using it for this purpose? We can have a conversation that's not affected by our intuitions, which have already been altered by the pervasiveness of predictive decision making in our society. Yeah, does that make sense? Give me a rough sense, thumbs up or thumbs down why we're doing this. Okay. And this case study is actually related also to driving. And we asked the reader to imagine a fictional state called West Dakota. And what West Dakota wants to do is they've noticed that teen drivers are getting into lots of accidents. Many of them are deadly accidents. And it's true, teen drivers are riskier than any other age group when you look at the statistics. And this risk has, there's two components to this. One is they might be getting into accidents because they're not sufficiently competent as drivers or not good drivers. The other is even if someone's a very good driver, they might be more willing to take risk. And so that's a separate component. So if we want to cut down on these traffic accidents, we have to treat these two separately. The traditional driving license system and learner's permit and all of that looks at the competence component. It doesn't in any way assess a person's proclivity for risk. Even if they know how to drive safely, how likely are they to speed and get into an accident, right? And it seems like a missed opportunity to be able to improve road safety. So you can see this is a very powerful rationale, and I'm not disputing this rationale. So far, I have no disagreement with the inclination for trying to incorporate risk assessment into this situation. But the way that this is typically done, the way this is done with predictive algorithms is, here's what might happen. So in addition to a driving test, you have a risk assessment. Now, currently, the only thing that's kind of a proxy for risk is if you're under 16 or whatever, you're probably considered too risky to have a license. And then there's a learner's permit, whatever. But let's say there's no minimum age requirement anymore. If what we're worried with kids is that they might either be incompetent drivers or they might be too risky, let's give them a driving test, make sure they're competent drivers, and let's do a risk assessment to calculate how risky they are. And yeah, a lot of them might be very risky, so they won't get licenses, but some of them might actually be better than adults, so they can have licenses. So the goal here would be to increase the number of drivers on the road who are eligible to drive while at the same time cutting down on road accidents. Again, super well motivated, right? So you build a machine learning model in order to predict, given everything you know about a driver, what is the likelihood in the next year that they're going to get into an accident. And so you do this risk assessment, you have a cutoff based on that, you start issuing driver's license based on this new approach, and you might find that this actually cuts down accidents while also increasing the number of teens on the road. And this is very similar to the research that's coming out of various other areas of risk assessment, including in the criminal justice system. But I want to pause and ask, if the system were put into practice, what could go wrong? I want to give you a minute or two to think about this. Again, if you've read the paper, you've already seen this. But if not, before I tell you what we think, it might be helpful to pump your intuition a little bit. And if you want to respond, feel free to go ahead. But if not, I just want you to take a minute to contemplate this. Again, this is the data on the screen. This measurement might be before the system was put into practice based on building a model and evaluating that model on a holdout set. That might be different from what actually happens when you implement the system, how people might respond to the existence of the system, various other things, and other criteria that might not be captured in the two goals that are listed on this slide. So take a minute to think about it. Thank you.
Maybe you could game the system. Can you hear us?
Oh, no, sorry. Yes, I can hear you. Sorry, did you say something?
So I said maybe you could game the system, depending on how the test is administered. Maybe you
exactly.
could come up with fake answers.
Yeah, game the system. That's a big one. Yeah, we'll talk about multiple ways in which that gaming could happen.
It could be practice exams. You just keep practicing until you get better and better format.
I unfortunately couldn't hear you from the back. Maybe if Norman could repeat that.
So repeat and I'll repeat.
I was saying you could do like practice tests. People create practice tests for all sorts of.
So along the same lines, maybe you could practice and until you get a pretty high score.
Okay. Yeah.
And I mean, obviously, I assume that's where you're going. Perhaps, you know, you could be miscategorized and, you know, associated with a group of people who has a terrible, terrible track record.
Yeah.
You could be the exception.
Yeah.
You have some other attributes, so perhaps
Yeah.
you're just different.
Yeah, exactly. Some types of accidents are worse than others, I see in the chat. Yes, that's great. Okay, so let's talk about various things that could happen. So one thing you might imagine is, okay, if this model works, why is it working? What could be some of the predictors of lower accident risk? What's likely is that it's going to be variables like neighborhood and wealth. And that could partly be because people in some neighborhoods are wealthier, are better drivers, but also it's very likely that it's simply because if people in some neighborhoods are wealthier, then they're able to afford newer cars, which are more expensive and safer. They have more safety features and therefore get into fewer accidents. And so this goes to Norman's point that, yeah, you're picking up these features. There's a correlation, but still, you know, if you don't fit into those patterns, you might be miscategorized. You might be a very good driver, except you're in the wrong neighborhood. So there's an issue of error there. There's also an issue of bias, related but separate issues. And this immediately also leads to gaming. Given how important driver's licenses are in people's lives, what might happen is people might consider this to be one factor in which neighborhood they choose to live in. And so this puts more demand on houses in wealthy neighborhoods, which actually further increases the price of those property values and further worsens inequality. If this seems too implausible, consider that this is exactly what happens today with school districts in the US. Wealthier school districts are able to spend more on kids' education, so it's extremely important. I can tell you as a parent, it's one of the primary factors you consider in where you move. And so that in turn makes those neighborhoods more desirable and property values further go up, and it's this feedback loop. Okay, so now let's consider what data was used for training this. Now, in the current system, before this was put into place, no one under 16 had a license, and therefore there are no under 16s in the training data. So that's one problem. You're training it on a different set of people, maybe slightly different, but importantly different from the people about whom it's going to make decisions. The other problem is that because accidents are relatively rare in the data, and for machine learning to work well, you need lots of data, very likely what's going to happen, and I've seen this over and over again in other deployed systems, is the developers are going to find some proxy for accidents. They might say, okay, speeding is highly correlated with accidents. So instead of trying to predict who will get into an accident, let's actually try to predict who will speed, because there are lots more positive examples of speeding in our data set, so our prediction accuracy will be higher. So already you're starting to see that the numbers that they may have evaluated, you know, it's increased or whatever accuracy by whatever number, they might be measuring the wrong thing. So you don't necessarily know that you will find the same accuracies when you actually put the model into production. And here's one that's, to me, the biggest issue with a lot of these predictive systems. You can no longer know in advance when you're going to be eligible for a license. And so you can't say, okay, a year from now, I'll be old enough to qualify for a license. And so you might start saving up for a vehicle purchase, or your family might start saving up. Those types of things become impossible in this situation. And here are some things that are a little bit more speculative, but again, we've seen in practice with other systems. This risk evaluation is not just this technical system, it's a socio-technical system. People are going to attach meaning to it, even if the system is not explained to them. People who pass the risk evaluation are going to think of themselves as safe drivers. And there's well-studied phenomena called risk compensation. If you think of yourself as a safer driver, you will actually perhaps unknowingly compensate by becoming less safe in your driving behavior. On the contrary, people who fail the risk evaluation might face negative social consequences of various kinds. I won't go into the details. Right, so the central claim in the paper is that if you look at all of these failure patterns, we're actually seeing that over and over and over again in criminal risk prediction and various other areas in which this kind of predictive logic is deployed. So let me now give you a slightly clearer definition of what I mean by predictive decision making. Let's consider 3 different types of automated decision making. So let's say the goal is college admissions. And you can do automated college admissions in a few different ways. One is you can look at how your current admissions people are evaluating applicants, and you can try to extract that decision-making rubric as much as possible in the form of a formula that you can automate, and you can have a hand-coded set of rules. Of course, most of the time when we're talking about automated decision-making, this is not what actually happens. It's one of 2 things. One, you could take the decisions of past admissions officers and train a machine learning model to mimic those decisions, right? So the model is trained on applications and labels attached to them by admissions officers, and the hope is that the model will evaluate future applicants in the same way that the average officer is currently evaluating them. So that's not what we mean by predictive optimization, neither of these 2 things. We mean a third thing, which is you find some objective criterion, such as future GPA, and what you do is you look at all the applicants you've admitted before, and you look at what GPAs they achieved after 1 year or after 4 years or whatever. And what your model is trained to do is actually try to predict that outcome variable. And this is actually the most common type of automated decision-making when you look at empirically what's deployed. People usually think about number 2, mimicking human decision-making, but that's not what's going on. Far and away, the more common one is category number 3, and that's what we call predictive optimization. And again, you can see the citation to our paper at the bottom. And the reason that predictive optimization is so compelling is that this AI vendor is going to come to the decision maker, the college, and say, look, you're getting too many applicants. You can't manually evaluate all of them, right? So we want to automate this. And we want to do that automation as cheaply as possible. And we know that there is bias in human evaluation, and we want to get rid of that bias. We don't even want to train on past human decisions. We want to train a model to predict some objective outcome, such as GPA. And then you build the model, and you can evaluate the model and make sure there's no bias in the model, and you can make sure that it's highly accurate, and then you can put it into practice. So that's usually the pitch. It's a very compelling pitch. You save a lot of money. It's a more accurate model. It's a fairer model compared to human decisions. It seems hard to dispute that logic. But again, as we go through in the paper, this simplistic narrative doesn't deal with a lot of the kind of second-order complications that can result, such as gaming that we talked about, that come up over and over again when these systems are deployed. So more formally, here are the 7 flaws that we claim recur across these applications. I'll go through each one. So good predictions might not lead to good decisions. The whole animating logic of predictive optimization is you train a model so that you can turn a decision-making problem into a pure prediction problem. That might work in a certain narrow set of cases, but it assumes that the world is immutable and you cannot change the phenomenon you're predicting. The only thing you can do is predict good and bad and separate the good from the bad. It leaves no room for the idea that some of the people in this category can actually be moved to that category. And when you look at the evidence for when people try to do that, that evidence is quite stark. There was a paper in Science by a lab called Ideas 42, I think, and some others that looked at misdemeanor offenses in New York City. And they found that there was a high rate of people failing to appear on their appointed court date. And this is the typical kind of problem where one would want to use predictive optimization. Okay, these people are too risky. We predict that they're not actually going to appear in court, so we should treat them more harshly or whatever. But what this group wanted to do is identify why people are not showing up and see if you can do something to change that. And what they found is that some of the reasons were people were just forgetting what the date was. And the summons, the form that's sent to them asking them to appear in court on a certain date was so confusing that they didn't understand what was being asked of them. So when they changed those 2 factors, when they texted people reminders of their court appointment and they changed the form so that it could be clearer, the rate at which people appeared in court dramatically increased. And excuse me, there's other research that says that a lot of the time why people are failing to appear in court is that they have to take care of their kid and then their nanny didn't show up last minute or something outside their control, right? So essentially what turning a decision problem into a prediction problem is doing is, first of all, it's failing to distinguish between someone actively choosing to skip town, not show up in court, versus they were in a difficult situation, their childcare provider didn't show up. So that's the first problem, right? That is the first thing that's being missed in this problem formulation. And the second thing that's being missed is the idea that you can actually change the outcome and that you're not just limited to predicting the outcome and foreclosing certain opportunities for people based on the prediction that they're too risky. So that's what we mean by there's a difference between predictions and decisions. The decision can be various types of intervention. It needn't necessarily just be, okay, you get a good result and you get a bad result. All right, so the next one, it's hard to measure what we truly care about. We saw this in the driving license example. It's hard to measure accidents. There are relatively few accidents, so you go for speeding violations instead. That could lead to the model not working well. Again, happens in criminal justice as well. If you're predicting who is going to commit a crime in the future, well, crimes are not observable. So what is almost universally used is who gets arrested for a crime in the future. So maybe it's true that your machine learning model doesn't have the biases of judges because it's not trained on judges' decisions. It's trained on the seemingly objective outcome variable of who was arrested for a crime, but it's not objective. It has all the biases of policing because there are different rates of arrest for different demographic groups for the same crime. Okay, so the third one, the training data rarely matches the deployment setting. So here's another example from criminal justice. This was by a nonprofit called Arnold Ventures, who I really respect. They're doing some amazing work in criminal justice reform. And I appreciate that they're even trying this. So they built a risk prediction model. It was done better in most ways than the commercial models. And it was trained on something like 150,000 defendants from all across the US. But one of the things that was hard to capture in this model is that the base rate, the prevalence of crime varies a lot between different counties in the country. So applying this model has kind of an averaging effect. If you had enough data from every single county, of course, then you can overcome that. But given how many counties there are, even 150,000 defendants across the US is probably not enough for this. And so what happened is that in some counties that are much safer than the national average, 10 times more defendants were being detained pre-trial, were being jailed than ideally should have been, given the low base rate of prevalence of crime in those counties. Social outcomes aren't accurately predictable. This is, a big factor behind why we call a lot of this snake oil. Even if you get everything right, even if you address, steps 1 through 3, what we're finding is that these tools are able to, at best, pick up crude statistical patterns. So the reason it's hard to predict who's going to commit a crime is that they haven't decided. Some crimes are premeditated, some crimes are spur of the moment crimes. It doesn't matter how much data you have in advance, that's fundamentally unpredictable, right? And so if your accuracy is going to be 60 or 70%, where random guessing is 50%, is it really morally justified for someone's freedom to be based upon a prediction that's only slightly more accurate than the flip of a coin? All right, I've been talking for a while. Let me quickly go through 5 through 7 and then open it up for some discussion. And then I have certainly have a bunch of other case studies. I don't have to get through all of it. We'll do as many as we have time for. So disparate performance between groups, discrimination between different racial, gender groups, et cetera. That is, of course, a well-known issue. It's gotten a lot of attention. I won't say too much about it, but the point we make in the paper is slightly different from the point that's usually made. Usually people say, oh, there's a racial disparity, so there's a problem, we shouldn't use it. That's, I think, a fairly weak argument, because in a lot of cases, you can just adjust the model to eliminate the racial equality. And we think in most of those cases, it's still illegitimate to use the model because, and here's the more nuanced argument, because the question of what constitutes an unbiased model is not a technical question. It's a deep moral and social question. When you look into the details of any particular application, it becomes very clear very quickly that there is no neutral, unbiased state. The moral decision you have to make is if there's a certain group in society that has historically been discriminated against and continues to experience the effects of that historical discrimination, to what extent should the decision maker who is doing college admissions or jobs or whatever it is take on the responsibility of correcting that existing inequality in society? And there is no clear neutral answer to that question. If you just do nothing, go for pure accuracy maximization, it's very clear that you're just perpetuating that inequality in society. But if you're going to say, okay, we're going to enforce full equality of outcome, it's also very clear that society has completely rejected that kind of kind of ham-fisted approach to justice and equality. And so there is a fine decision of drawing some middle ground that's going to make every stakeholder not too unhappy. That can't be done in a general way. And you have to have this normative, painful discussion every time you put a decision-making system into place. And so, in light of all that, the core problem with predictive optimization and discrimination is that you take that important decision of where to draw that line of adjudicating between different groups in society, you take that decision away from the decision maker, the judge or the college or whoever the decision maker is, and put it into the hands of some completely unqualified group of engineers or whoever is developing this machine learning product. They're the ones who are making this highly loaded normative decision now. And they have no legitimacy. Society has not entrusted them with the job of making that incredibly complex and nuanced decision. So that's really, in my view, the discrimination issue. It's not simply observing that there's a racial bias. Okay, so number 6 is the idea that there's a kind of bait and switch going on. What these AI vendors will typically do is they'll come to the decision maker and say, look, you're an HR department, for example. You're getting hundreds of applications for each open position. You can't possibly manually review all of them. So use our AI tool, right? So the way the tool is being sold is efficiency. You can cut the amount of human labor that goes into reviewing those decisions. And yet, when the model inevitably makes mistakes, the AI vendor retreats to the fine print and says, oh, no, you shouldn't use it in a purely automated way. There always needs to be a human in the loop. Which is contradictory, because if there's always going to be a human in the loop, it's not clear that you're even realizing any efficiency benefits whatsoever. So this is, again, a tension that comes up over and over. And finally, predictive optimization doesn't account for strategic behavior, people trying to game the system. That's something we've already discussed. Okay, so yeah, I'd love to see what your reactions are up until this point. Particularly curious if you find this like broadly convincing, thought-provoking, unconvincing, where you are on the spectrum, or anything I can clarify before I move on.
Anybody? Okay, I'll speak first, if that's okay, but I'd like to see others also jumping in. So I think you've made obviously some very convincing arguments about these 7 different flaws. I also heard you say implicitly that nevertheless, predictive analytics can also have some benefits. At the end of the day, all these decisions need to be made. If they're not made with these systems and they're made by people who are even worse, perhaps that's not necessarily an argument for not using these techniques. And I've not heard you say that we should not use these techniques. I think you've been much more nuanced in what you've said. As you know, there are some laws out there. If you look, for instance, at the EU AI Act, right, they've got certainly provisions against social scoring, which is the use of these types of techniques for under a specific context. And then there's the whole, AI governance space that says perhaps we need to at least, organize our thinking, be clear about the disclosures that we make, come up with various types of criteria to evaluate whether these things are beneficial or not, or they're going to be perceived by different stakeholders and the like. So I was wondering if that's where you're going to go next with your presentation, or whether
yes. Thank you. Yes. A super important question. Yes. So far I've said there are many flaws, but I haven't said what we should do about it. Should we just throw out predictive optimization? I think not. I think it really depends on the application. So I was going to actually let me just go to the next slide for just a second, but then I will come to your question in detail. So these are the specific applications that we considered. So let me just briefly explain. Pretrial risk I've already talked about. Child maltreatment. So these are situations where a child is at risk of being abused by their family. And so it's a largely human system, but an algorithm plays an important role in trying to predict what that risk is. And if the child is too risky, there's an interview. Is that too much risk? There's an interview with the parents and so on. And the child might potentially be removed from the family and put in the foster system. Job performance, we've discussed. School dropout, that's fairly clear, I think. Creditworthiness is, FICO scores, that kind of thing. But using a lot more kinds of data, including like from social media. Suicide. So Facebook in particular on Meta, both on Facebook and Instagram, uses machine learning models to predict if someone might be at imminent risk of self-harm or suicide. And if it's predicted to be yes, then it's escalated to the police or a social service worker or someone like that who pays that person a visit. And then there's life insurance. So I think what we should do really depends on the situation. If you're looking at a bank that's making decisions about lending, they have to discriminate between people based on risk level. Otherwise, they will simply go out of business. And similarly, in insurance, you have to have some level of discrimination. It's a very question of which variables are allowed to discriminate between people and which variables are not allowed. And in my view, the set of variables that society has collectively seems to have decided is admissible is so small that you don't get much benefit from any kind of newfangled machine learning models compared to just plain old sort of logistic regression. And that's actually what we've seen in a lot of these cases. Even when they are using statistical techniques, you get so little by moving to these more modern methods. And the fact that they're more kind of black boxes and are subject to maybe more distribution shifts, more unpredictable effects, means that these decision makers have decided that there's not much benefit in using them compared to more traditional statistical analytics. So yeah, sometimes we have to use them. Sometimes we can consider using simpler statistical methods as opposed to more modern machine learning. And we have to consider what the alternatives are. Sometimes there's no alternative, but sometimes, in criminal risk prediction, for instance, there are so many attempts at criminal justice reform. For instance, there are things like ankle monitors. So does it always have to be this binary thumbs up, thumbs down decision about whether someone's going to be jailed or not? So when you increase the option space, then you can avoid a lot of the pitfalls that we've identified. So that's the third thing. And the fourth one is, as you pointed out, Norman, sometimes what needs to happen is there needs to be a lot more transparency and accountability. So like in this Facebook or Meta example, I think it's incredibly valuable that they have this intervention in the lives of people who might be suffering from mental health issues. But the way they have implemented it, there's a lot of secrecy. There's very little accountability. There's whole papers on, what are the problems with the system. So I agree that as implemented, the system is a problem, but we're not claiming that prediction should be thrown away. So it's a mix of different responses for different applications.
From your talk, it's evident that the machine learning models themselves are they are dumb. But what we are doing is we are using a different fairness metric for evaluating those models and the decisions made by them. So if for, say, any of the tasks which you mentioned, if we as a society come up with an agreeable fairness metric, so like if this is the input and we say that this is the fairness which we want, and we come up with that, will that be a possible solution for this problem?
Sure. Yeah, good question. So to be clear, fairness is only one item out of these 7, right? So it could be a possible solution to number 5, first of all, but it wouldn't do anything about items 1, 2, 3, 4, 6, and 7. And even for number 5, yes, it can be a solution. Society as a whole can try to have more consensus on what is fair and what is not. The thing that is often forgotten, though, is just how expensive that process is. There's a really nice book called Voices in the Code by David Robinson, that looked at the process behind, again, society as a whole, but especially affected people determining what is fair for the kidney allocation algorithm in the US. Again, enormously consequential, right? Life or death decisions. And there were a series of, hearings and various kinds of processes to get everybody's input, make decisions, see what's going wrong with the system, tweak it, and so forth. The crazy thing is that it took 10 years, right? So the human cost of debating and determining what is fair and what is not, in my view, tends to typically overwhelm the cost savings that you often achieve using automation. And that is, it's a hard point to understand, but when we look deep dive into case studies of what it actually takes to, determine this fairness metric, as you put it, it turns out it's like dozens of people working for 10 years.
So, this is a privacy seminar, and there are lots of interesting links, for instance, with GDPR, right, where you've got the right to object to automated decision processes. And so beyond transparency and metrics and trying to aim for fairness, which is very elusive to define, having processes whereby people can say, hey, I'd like a human being to review that decision. I'd like to be able to understand what data went into that process, right? Those are additional ways of potentially mitigating those flaws that you've identified.
Exactly. Yeah. Thank you.
I actually wanted to pick a little bit more at the human in the loop. Maybe this is coming on further in your talk, but could we maybe talk more about what role humans should be playing in this predictive optimization scenarios, and kind of how AI can help them and where it might hurt them?
Yeah, absolutely. I think there's a spectrum between full automation and a person involved in every decision. I think there's a vast middle space that has not been adequately explored. There are various things we can imagine. So, for instance, there's a literature on what are called algorithmic absurdities. These are cases where, because of the way in which you have to reduce the complexity of a real-world observation into rows and columns for your predictive model, you're losing something that would be very obvious to a human, but kind of invisible to the model. So a good example is in a setting where the state was providing disability assistance to people, and this is for wheelchair users. Their information is put into a standard format based on a questionnaire. And one of the questions is, how much pain are you feeling in your leg on a scale of 1 to 10, for instance? And there was a case where there was an amputee and they answered 0 because they didn't have pain in their non-existent legs, and that is treated as identical to someone whose legs are perfectly fine, right? So this is an example of an algorithmic absurdity. So I think a little bit of human intervention here, perhaps assisted by AI models. So actually, this is a good opportunity to see if there are ways to apply large language models here, because to some extent, not to the same extent as a person, but to some extent, they have common sense. You could imagine a large language model being given as input, okay, here's a textual description of this person. Here's how it's been translated into this particular, CSV file, basically, or the SQL database. See if the way in which the data has been coded is doing justice to this textual description. You could imagine a model flagging potential algorithmic absurdities, and then a person goes in to do a deeper dive on that, right? So that's one example. Another example is if you're concerned about fairness, for instance, instead of figuring out a priori what the fairness metric should be, and then designing an algorithm that enforces that fairness metric, it's an area where lots of things can go wrong, gaming, distribution shift, et cetera. To have a person regularly inspecting, okay, like let's look at the decisions over the last month. Are there any anomalies? Are there any sudden changes in the distribution of outputs from this month to last month? These are all kind of standard engineering practices in other areas. So for instance, if you're operating a recommendation algorithm on social media, right? You're constantly monitoring dashboards with hundreds of different metrics. And that's a very different model from a person examining every decision to put an item in a person's feed. Obviously, that won't work. That's trillions of decisions per day. But examining hundreds of metrics on a regular basis is something that a team of humans can do, right? So there has been a lot of innovation in many ML applications on coming up with things that are in between human in the loop, which is one extreme, and full automation, which is another extreme. It hasn't been done that much in these kinds of automated decision-making systems for consequential tasks, and I think that's a big opportunity.
We have other questions, or should we allow Arvind to continue? I think we're going to let you continue.
Okay, sounds good. So Norman, give me some guidance on how long I should go.
So we have until 1:50. Usually, I mean, you've made this interactive as you go, and so in a way, you're consuming your 15-20 minutes of Q&A as you go. So the hard stop is 1:50. Feel
Okay.
free to potentially stop earlier if you'd like and open up for discussion.
Okay, sounds great. Great. So here's another case study from the paper. I see there's something in the chat, but I apologize. Let me do this case study and then I will look back at it.
The question about in the chat was, what do you think the role of regulation should be?
Yeah, the role of regulation. Let me just say some brief words about that. So you can imagine a spectrum from really low touch interventions to more kind of extreme interventions. On the lower intervention side, just ensuring that decision makers have full information about various things related to a model's properties. So in a lot of cases today, these models get audited for bias, but they never get audited for accuracy, which actually is surprisingly hard to audit for compared to bias. The big difference is that, let's say you're in a hiring situation, you can do a bias audit by having a past set of CVs, putting them through the model, and seeing what are the outcomes on average for different demographic groups. And you can tweak that, there are more complex fairness metrics, right? But you can do it on the spot. But if you want to evaluate accuracy, it's not a prediction problem, it's a decision-making problem. The only way to rigorously evaluate accuracy is using the equivalent of a randomized controlled trial. You have to hire some people based on the recommendations of the algorithm and hire other people, using your current process, see what happens after a year or 2 years. That is like several orders of magnitude more expensive, right? And so basically that never gets done. And if regulation can incentivize, at least to some degree, having some understanding of what the accuracy is, what the distribution shifts are, and those types of things, decision makers can make much more informed decisions about whether the product will do what it claims to do. That's just one idea. There are many other ideas for regulation. Okay. So there have been many things that have been criticized and obviously somewhat politicized issue about COVID vaccine allocation. But in the early days, when a lot of people wanted to get vaccinated, I don't know, 60%, 70% of people, but the amount of vaccine available was much less than that. It was a problem of allocating the scarce supply in order to meet the demand as best as possible, which is very similar to the problem of like hiring. You have limited available positions, lots of people want to apply, how you pick people, etc. And the way that this happened, it was a very human process. There was hardly any automation that was used. But personally, I think this was done really, really well. And there's a lot to take away for automated decision-making. Now, first of all, if they had tried to automate it in the straightforward way with predictive optimization, what would that have looked like? You try to train a model to predict how likely someone is to die without the vaccine, and then you score everybody in the country on that basis, and then you pick from the top, right? That's actually how a lot of systems work. That's how that's how organ transplantation algorithms work, for instance. You score all of the thousands of people on the waiting list by risk, and then you pick from the top. And we recently did a case study showing how that goes wrong sometimes. But that's not what happened here. And as you might recall, it was a much more complex allocation system. It was not based on one single numerical criterion. So one criterion that they did use was prioritizing healthcare workers. And I find this super, super interesting. A lot of people's intuition is that, oh, this makes sense. They prioritize healthcare workers because healthcare workers are working in the hospital where the germs are floating around. They're at highest risk, so they should be prioritized. That was not at all the rationale. They were not at higher risk. If you look at the numbers, nurses and doctors were actually, I think, at lower risk than many, many other occupations because they had proper N95 masks at a point in time when most of the country was not masking, et cetera. So they were not at particularly high risk. That was not the reason. This was not for minimizing the number of deaths. That might seem shocking. Why am I defending a criterion that doesn't result in minimizing the number of deaths, maximizing the number of lives saved? This is actually not a utilitarian logic. It was deontic considerations, and that means doing our duty to these folks, to healthcare workers. And the logic was that for 9 months, they had put themselves on the line, working every day when a lot of other people got to stay home, saving so many lives. And so we owe them. This is something that society owes them to show our gratitude and our respect. This is something they deserve. And that was the rationale behind why they were prioritized first. So in many, many decision-making systems, ideally, there should be some deontic considerations. But in a machine learning-based approach, it's just infuriatingly hard to try to incorporate all of that into the objective function that you're trying to maximize. Another high-risk group was based on age, for instance. And another one was based on essential workers. So the age groups, 70 plus aged people would be prioritized first after the healthcare workers. So that was based on maximizing lives saved. So if you had used an ML algorithm, it would have suggested something similar, perhaps even more nuanced. There can be, immunocompromised people who are younger but still at high risk, et cetera. But the essential workers, that was, again, it was not based on maximizing lives saved. It was not based on deontic considerations. It was based on economic considerations. We need people, who are dealing with our supply chains, for instance, to continue working. Otherwise, the economy will shut down. And so again, it's a criterion that's hard to capture in a purely automated decision-making system. It's a bit of a nuanced point. And another nice attribute that the system had, because it was not based on fancy machine learning, was that each state basically came up with its own set of criteria and published it as a 2-page or 3-page PDF. This is the order in which we're gonna allocate vaccines. And it has a property called simulatability. Simulatability is the ability of any individual, a non-technical person, to keep the whole decision-making algorithm in their heads and to be able to reason about it. And that's super important to allow for a public debate and a perception of legitimacy, to avoid a perception that this is a black box. Machine learning algorithms are often called a black box, but you can take these models and you can do lots of experiments on them. So it's not, in many ways, I disagree with the black box label, but it is true in one sense that because everyday people cannot understand them, even if experts can understand them, it creates a distance between knocked off my mic. It creates a distance between the people who are subject to the decisions and the people who build, administer, analyze, deploy the system. And that distance is often problematic for legitimacy. It also allows individual planning. You know when you're going to become eligible. This is the equivalent of the driving license situation where you never know if the risk predictor is going to say you're sufficiently low risk or not. It also allowed flexibility. At the federal level, it was delegated to the states, and the states often further delegated it. And this is very helpful. In different states, people might have different norms. And it made it more flexible because the amount of supply, the amount of demand as well, people's views on vaccines, those were all changing in real time. So what it allowed doing is to say, okay, this is the highest prioritized group, healthcare workers, and then immunocompromised and older people and essential workers. So that's decided. But who's going to come after that? We don't know, right? So you don't have to decide the whole policy ahead of time before you actually start implementing the policy. These are all aspects of flexibility that we take for granted with any real-world policy, like vaccine allocation, but are actually close to impossible with an automated system. You have to determine the whole policy ahead of time, and then if you have to change it down the line, you have to redo the whole thing. So these are all aspects that are missed, I think, when people only look at accuracy and fairness metrics for automated decision-making. Okay, maybe I'll pause here and then try to do maybe one or two case studies.
Do you have questions? Yes, Isabel, go ahead.
So I just had a question about your last point where you said that for flexibility, for an ML model, you have to kind of restart the process or like do a part of the process over again whenever new features are added into the situation. But I did kind of want to ask that aren't like more advanced ML models able to train while still being used? So if there's like new information being brought in, it can continuously train on that and like, adjust its output while still being like used by like the public or whatever company.
Sure. Here's the challenge, right? So to even start training an ML model, you have to obviously define a loss function, an objective function, and a target variable. And that target variable has to encompass, usually would be a linear combination of all of the kind of different values that you care about, right? So most typically there is an accuracy term and a fairness term, and there's a lambda, right? A parameter that trades off between them. And then if you have a more complex process like this, where you care about a lot of different things, economic considerations, life saved, et cetera, you have to define ahead of time what are the entire list of things that matters and exactly how you trade those off against each other. And you have to do that to the satisfaction of every stakeholder, right? And that's when you can even begin to start training the model before you make the first decision that comes out of the model, which is, again, very different from the situation here. You can start by prioritizing one or two groups while you're thinking about how the rest of the people should be prioritized.
Sounds like this is leading us to reinforcement learning with human feedback.
Yeah. Yes. So there are ways to incorporate ML here. So within any particular group, for instance, you can rank people using ML, and that's I think that would still be useful, but would not lead to a lot of the really serious issues I've been talking about. Okay.
Do you have other questions?
So
people are eager to see the rest of the slides.
Yeah, sounds good. So here's another case study. So I've been talking a lot about kind of how our intuition goes wrong. So in criminal justice, for instance, we have accepted that this is the way we do things. I'm advocating for kind of rebooting our intuition to see these as much more problematic than they are, than they have currently been perceived. I want to do a case study where I want to argue the opposite. I think it's important for experts to be able to identify these mismatches between our own and everyday people's intuitions and what we conclude after analyzing the facts. And sometimes as experts, we need to update our intuitions. A lot of the time, everyday people need to update their intuitions about some of these algorithmic decision-making systems. And I think it's the job of experts to communicate with the public to help people update their intuitions. So one good example of this is what I think was a fantastic application of automated decision-making using machine learning in Flint, Michigan, which, as you might know, had a big problem with lead in water pipes, which is, again, kind of a life or death issue. So they had to rip out the lead pipes from every house in the city that had it and replace them with new pipes. That's a years-long, extremely expensive process. It's still not been done. They've been working on it for most of a decade. And the city just doesn't have the budget to inspect every single house and, rip up every single house. So what should they do? So to deal with this, some folks from DeepMind, I want to say, but I forget, they built a predictive model. So they used data from some houses where they had labels on whether there were or weren't lead pipes. So the fundamental problem is you might be the owner of a house, but you don't know if your own pipes are lead or not. And there are no records that the city keeps that would allow them to figure that out. So they built this model so that you can predict if a house that has not been inspected has lead pipes or not. It's based on its age, it's based on its location, based on the type of house, various other things. And it worked pretty well. I want to say it had an AUC of well over 90%, if I remember correctly, area under the curve, as opposed to these criminal risk prediction models, which are like barely better than random. So why is that? So the answer is that this is not actually a prediction in the sense of predicting the future. It's a prediction in the ML sense we call basically all supervised machine learning prediction, but that's a silly use of the word prediction. This is a very different problem from all the other problems we're discussing. We're not trying to predict something that's going to happen in the future that may or may not happen that has not been decided yet. We're essentially trying to predict the past, what happened 70 years ago when this house was built, right? So you can imagine that because there's no actual uncertainty about this, that you can use various attributes of a house and you can have a model that predicts with a fairly high degree of accuracy. So that was the first difference here, why this model is more morally legitimate than in the other cases. And also, again, there's no alternative. Earlier, I was talking about criminal justice reform and so on. There's nothing like that you can do here. You don't have enough money. You can only inspect a subset of houses. Which houses are you going to inspect? That's the only decision that needs to be made. That's the second thing. And the third thing is some of the reasons why a lot of people morally, intuitively felt this was problematic are things like, hey, why is my house not getting an inspection and my neighbor's houses? Right. And then there are also big differences between neighborhoods. And it's like, hey, why is there so little happening in my neighborhood, whereas this other neighborhood is, I see trucks there every day doing something. So those types of things. And this is a part of the talk where I'm gonna, if you will give me the liberty of taking 30 seconds to just step outside my area of expertise and speculate a little bit. I think there are like profound evolutionary reasons why our moral intuitions about arbitrariness are all wrong. So if you think about our kind of traditional tribal environment, if a decision is happening arbitrarily, it seems like this other person is getting an opportunity in your tribe and you're not, it's usually not arbitrariness. It's usually not, true randomness in the sense of a flip of a coin. It's usually what's happening is that whoever is the tribal leader who's making that decision has some secret favoritism towards the person who's getting the opportunity. And so we just have this, I think, deeply embedded aversion to seemingly arbitrary decisions because in our ancestral past, those would have been really problematic things. But today, obviously, when you're using these machine learning models, there's no secret hidden intent there. When you observe arbitrariness, it's usually that there is, in fact, some reason behind the model. It's not so obvious for a person to understand, or often it's the result of actual randomness in the decisions, which we often argue, I'm not going to go over that here, which we argue is often a good thing and the only way to make decisions fairly because there's no other legitimate way to adjudicate between two equally qualified people for some opportunity. And so it's one thing when we have a moral intuition, based on racial, gender discrimination, things like that. Those are areas where our moral intuition is correct. And there are many cases where we have a moral intuition against arbitrariness or randomness. And those are cases where our moral intuition, I would say, is wrong when it comes to automated decision making. And it's our job as experts to explain to people why that intuition is wrong. Even though they perceive something as unfair, it's actually not unfair. It is, in fact, the most fair way to do things. But that did not happen in Flint, Michigan. There was a lot of discontent about the use of this machine learning model. And there were also a whole bunch of other bureaucratic failures. This model was being used for a couple of years. They made a lot of progress, and then they scrapped the model, and now they're basically digging up houses randomly, and they're operating at like 10% of the efficiency of what they were before. Some of the numbers I'm not sure on, I'm going from memory, but really qualitatively what is happening there is a travesty, and it's a failure to use a machine learning model which could have done a lot of good. Okay, again, I want to maybe pause for reactions, thoughts, questions, comments.
Yeah, I mean, it's really interesting that it's a case where the machine learning could have helped, and and it seemed like they have the metrics to show that it was helping, but it was kind of a PR, I guess, failure to.
Exactly.
Do you have any intuition as to what aspects of the use of this algorithm was the most problematic in terms of communicating to the public and what the public officials could have done better?
Yeah, I mean, as far as I know, there was no communication with the public. someone hadn't read this investigative report, they wouldn't have known that an algorithm was being used, right? All that they see is where the trucks are, and it seems like there's a lot of preferencing of certain neighborhoods and maybe certain individuals going on. And bureaucrats are notoriously awful at public communication, so I wouldn't be surprised if they had done nothing at all to explain any of this to the public.
I think we've got about 5 minutes left, so we're going to let you go through the last few slides.
Yeah, I mean, I don't want to start a whole nother case study at this point. I mean, this is kind of an infinite scroll, if you will, of case studies that I have, so I can keep going for as long as we want. But yeah, I'll just say that if you're interested in these things, we recently put out a case study I referred to earlier about the UK liver transplant matching algorithm. That's another case where I think they should use predictive logic, but there was a failure on multiple levels, transparency and communicating with the public. It ended up being a discriminatory algorithm. Again, unintentionally, there are ways it could have been fixed, but wasn't. And there was a difficulty in choosing the target variable correctly. That was another major component that went wrong. And the write-up is on our blog, aisnakeoil.com. And it's one of the first few articles. That's a live debate. I think they're trying to tweak the algorithm as we speak. So hopefully something will come out of that. And I also mentioned that as an example of the fact that a lot of these systems, even though there was some public debate and discussion and so on, often don't get nearly enough critical analysis, that if you're an expert at this sort of thing, you can really make an impact, I think, to some of these decision-making systems by writing about it, by organizing people to rally against a particular, bad way of doing things, or by working with some of these bureaucrats or other decision makers in order to help them do their job better. So there's a huge opportunity for a positive impact in getting automated decision making right.
I've really enjoyed your presentation and the way you've helped us all, I think, organize this space in our minds in terms of different flaws and all the different things that can go wrong. In some of these areas, there's some amount of progress. For instance, fairness, there are various types of tools. I mean, fairness is impossible to define, obviously.
Sure.
There are, a number of different metrics that have been developed. There are various types of tools. You go, to Amazon and their pipeline and so on, and you've got readily available tools that you can use. Some of the other issues you've talked about are less well understood, I think. But I was wondering, whether, and perhaps that's where you're going, do you envision some kind of a platform or a tool where perhaps, one day, anyone who is working on predictive analytics would be able to take that tool and, produce various types of reports and have various types of, functionality that could potentially add to their model to sort of mitigate some of these flaws you've identified? Is that something that you envision?
Yeah, for sure, for sure. There are people working on research that hopefully will one day lead to those tools. I don't think those tools are there yet. I'll mention a couple of examples. There was a great workshop organized by Lydia Liu, who's one of my colleagues, as well as various other people in Banff. It was called something like Prediction and Intervention in Social Systems. And that's addressing primarily one of the flaws that I talked about, but some of the other ones as well, but especially number one here. So when we're faced with these decision-making systems, can we use machine learning to actually attack the decision-making problem, which often requires causal inference, instead of pretending that it's a pure prediction problem? And there's lots of research on how to incorporate causal reasoning and machine learning and hybridize them together. So that could one day be more streamlined and become an easy to use tool. Another example is number 3 here, which is distribution shift. There is a lot of work on distribution shift as well. Some of my colleagues here, led by Matt Salganik, as well as I'm sure many other people at many other universities, are working on that. Again, not quite a tool yet, but I think we'll be there someday.
I think we have one more, a couple of more questions.
Oh, it's a little bit of a longer one, so it's okay if you don't have time.
Okay.
We have 30 seconds.
We have one question.
Oh, yeah, I have a question. So I think just based on your talk, my interpretation of algorithmic
decision making is that there are several issues with both the technology aspect and people, going from the biases in the data set used to train the model, algorithmic absurdities, as well as the biases of the humans in the loop. So what's your vision for how like engineers and policymakers should work together to increase the transparency, trust, and fairness of the algorithmic decision making?
Sure. Yeah. I mean, there's lots of things one can say. That's a very broad topic. So, but I'll pick one thing that's often missed, and it's not. It wouldn't be, the first answer I would give to your question. But since we're short on time, I wanted to give perhaps a less intuitive answer to your question to give something to take away for thinking about more, which is that you can use automated methods to highlight the biases in human decision making. And that's often much, much easier and less problematic than putting an automated decision making system into place. So maybe that should often be the first step. Instead of trying for the ultimate goal right from the get-go and running headlong into all of these 7 problems, right? Take the existing human decision making system, use machine learning to identify the biases, take that to the decision makers and ask them, do you agree this is a bias? Or is there some reason I have not recognized that you're making decisions this way? Sometimes the answer is yes. So one supposed bias in the way that judges make decisions is that statistically speaking, younger defendants are more risky, but judges are more lenient towards them. But the reason for that is that judges are not doing a pure risk prediction problem. They're taking into account the fact that younger defendants have more opportunities to, get their lives back on track and that sort of thing, right? So they're actually taking into account, number one, the difference between predictions and decisions. So start with an analysis of human decisions, have a conversation with the decision maker, use it to improve the human decision-making system, while at the same time using it as an opportunity to understand the existing system better in order to then design an automated decision making.
Just a minute, please. So let's give our speaker a big round of applause before we get completely kicked out of this room. Arvind, this was a great, great talk. Thank you so much.
Thank you.
I hope to see you in person sometime soon and to get to invite you for lunch or dinner. And
Wonderful.
we can catch up some more. Thank you again.
Bye.
Thank you, everybody.